Good day, class! Let's now proceed to our lesson 3 entitled The Nature and Propagation of Light. As an overview, blue lakes, ochre deserts, green forests, and multicolored rainbows can be enjoyed by anyone who has eyes with which to see them. But by studying the branch of physics called the optics, which deals with the behavior of light and other electromagnetic waves, we can reach a deeper appreciation of the visible world. A knowledge of the properties of light allows us to understand the blue color of the sky and the design of optical devices such as telescopes, microscopes, cameras, eyeglasses, and the human eye. The same basic principles of optics also lie at the heart of modern developments such as the laser, the optical fibers, holograms, optical computers, and new techniques in medical imaging. The importance of optics to physics and to science and engineering in general is so great that we will devote the next 3 lessons to its study. And in this lesson, we begin with the study of the laws of reflection and refraction and the concept of dispersion, polarization, and scattering of light. And along the way, we compare the various possible descriptions of light in terms of practices or particles, rays, or waves, and we introduce Huygens principle, an important link that connects the ray and wave viewpoints. At the end of this lesson, you will learn or you will explain the wave aspect of light as well as the particle behavior of light. Give the laws of reflection and refraction. State the conditions necessary for the occurrence of reflection, refraction, diffraction, and polarization, and discuss Huygens principle. For the learning content, 3.1 The nature of light. Until the time of Isaac Newton, most scientists thought that light consisted of stream of particles called corpuscles emitted by light sources. Galileo and others tried unsuccessfully to measure the speed of light, and around 1665, evidence of wave properties of light began to be discovered. By the early 19th century, evidence that light is a wave that had grown very persuasive. So light is a wave. In 1876, James Clerk Maxwell predicted the existence of electromagnetic waves and calculated their speed of propagation. This development, along with the experimental work of Heinrich Hertz, starting in 1887, showed conclusively that light is indeed an electromagnetic waves. So the discoveries of nature of light was a combination of the ideas of the scientists, namely si Isaac Newton, si Galileo, James Clerk Maxwell, and Heinrich Hertz, and other scientists na successfully interpreted that light is an electromagnetic wave. The 2 personalities of light. The fundamental sources of all electromagnetic radiation are electric charges in accelerated motion. All bodies emit electromagnetic radiation as a result of thermal motion of their molecule. This radiation, called thermal radiation, is a mixture of different wavelengths. We humans also radiate thermal radiation. Yung thermal radiation, yung heat na nare-radiate ng ating katawan, can be measured by using devices. For example is yung mga thermal imaging devices. At sufficiently high temperatures, all matters emits enough visible lights to be self-luminous. A very hot body appears red hot, like in this figure, or white hot. Thus, hot matter in any form is a light source. Okay? Remember this, hot matter in any form is a light source. For example, our sun. Though our sun is considered a star, we assume that all stars are emitting light because they are extremely hot. Familiar examples are a candle flame, hot coals in a campfire, the coils in an electric room heater, and an incandescent lamp filament, which usually operates at a temperature of about 300 degrees Celsius. This is why our incandescent lamp, fluorescent lamp, any form of light bulb or LED bulb are emitting hot temperature. Because, again, hot matter is any form of light source. For example, in this figure 3.1, it is an electric element. Tawag dito is electric stove. Since the temperature is high enough, it emits a desirable amount of visible light, nagiging red hot siya. Light is also produced during electrical discharges through ionized gases. The bluish light of mercury arc lamps, the orange-yellow of sodium vapor lamps, and the various colors of neons or neon or yung mga neon signs are familiar. If you have recalled your general chemistry, there are 5 types of matter, and one of the types of matter is the plasma. Yung sinasabi ditong ionized gases, it is a form of plasma na usually nakikita natin as neon, like the aurora, for example. Ayan siya, yung mga ating mga neon LEDs. Ayan siya. They are ionized gases, and they are one form of plasma. Okay? Now, the light source uses a material called phosphor to convert the ultraviolet radiation from a mercury arc into a visible light. This conversion makes fluorescent lamps more efficient than incandescent lamps in transforming electrical energy into light. Ano ba ang pagkakaiba ni fluorescent lamps kay incandescent lamps? So, fluorescent lamps is yung mga long lamp na ginagamit natin sa loob ng bahay. Whereas itong si incandescent lamp, titingnan natin siya. Si incandescent lamp is yung mga bulb na nag-emit ng yellow color. Dati common ito, pero ngayon nasasapawan na sila ng LED. So, next. In most light sources, light is emitted independently by different atoms within the source. In a laser, by contrast, atoms are induced to emit light in a cooperative coherent fashion. So, kay laser naman, kaya siya nakaka-form ng kahit malayo is buo pa rin yung itsura, it is because yung light na na-emit is masyado silang na-compress or kumbaga sa point source is halimbawa, sige. So, kay laser naman, meron niya siyang tiny particles, tulad nito, tiny particles ng mga light na nag-emit and naipon into one point, creating a very, very thin lines of light. Okay? This is usually made from, I think, laser made of ruby. Okay? Yung ginamit na glass para maging pointed or maging pino si light is a ruby. Okay? Kaya minsan yung mga high-end lasers ay mahal, pero since common na siya, as for the law of supply and demand, since marami na yung supply, nagiging mura na si laser for now. But there are different types and different uses of lasers. Yung mga common na nabibili natin is just a low-end type of lasers. Siguro yung kanyang reflective cylinder is just made up of some glass na hindi ruby or some crystal but ruby. Next. Okay, sabi dito, the result is a very narrow beam of radiation that can be enormously intense and that is much more nearly monochromatic or single frequency. Okay? Single frequency than light from any other source because lasers are used by physicians for microsurgery in a DVD or Blu-ray player to scan the information recorded on a video disc and in the industry to cut through steel and to fuse high melting point materials and in many other applications. So, as what I have said, lasers can be in any form and in any uses. Okay? Nagkakaiba lang sila sa kanilang frequencies. Ano itong frequencies? Ito yung kanilang sa uses ng mga surgery natin. Yung mga laser na yan is emitting very high frequencies that it can cut our tissue muscles. Okay? Yung mga ganong klaseng lasers are high-end and siguro ginagamitan na ng mas precise na reflective cylinder and as I've said, they are usually ruby rod or any form of stones or crystals. Ayan, ginamit siya sa mata. So, no matter what its source, electromagnetic radiation travels in vacuum at the same speed. The speed of light in vacuum is defined to be 2.9979248 times 10 to the power of 8 meters per second or simply 3 times 10 to the power of 8 meters per second. Usually, 3 significant figures lang ang ginagamit. So, 2.99 or 3.00. The duration of 1 second is defined by the cesium clock, so 1 meter is defined to be the distance that light travels in 1 over 3 million or 300 million or 299,792,458 seconds.